Uh, Welcome you back to this course on the inorganic chemistry of life, principles and perspectives. And what we have looked at in the previous lecture was as follows. I attempted to convince you that there are inorganic ions which are present in enzymes. How they are present, etc., I have not told you, that we will discuss later on, but they are doing wonderful jobs. Each one of these has an important role. It could be an iron ion, it could be a zinc ion, it could be a copper ion. These are the three examples I have taken. This could be a manganese ion, it could be a molybdenum. So, I have taken examples for these just to give you a feel that there are inorganic elements which sit in the biological systems and do real wonders. Okay, now let us continue that spirit and get into further aspects of it. And in this particular slide, you can see how do we understand all of this. Okay, so how do we understand all of this? So, in order to understand all of this, we have to understand the inorganic chemistry that is going on in the biological systems. Okay, and particularly in the biological systems, in the process of the biological molecules, even cells, etc. And also by studying these inorganic chemistry processes in the life. So, how these inorganic elements affect the life processes. So, therefore, overall we will try to look at the role of inorganic chemistry elements in biological systems, in simple biological molecules, in cells, and in some examples for the organ, so the body, and how the supplements and the drugs as well. So, therefore, we will go one by one into these aspects. So, now the question comes is that for a chemist, the chemist's tool is the periodic table, and everyone knows the periodic table of elements, which is introduced as early as 9th, 10th standard in the high school. Therefore, you have a large number of boxes here on the left side, in the center, and the right side, and the bottom, and come to this a bit later stage, and you have elements spread over all this. So, when you have elements of all these, as you can see that so many elements you have, is it true that all of these elements are important in the life, or only certain elements are important in the life? This needs to be understood. So, as we keep going further in the next few slides or so, we will certainly understand this. So, right now let us say yes, there are a large number of elements. In fact, today it is 118 elements are there, though this particular thing shows 104 elements, but we have 118 elements of this. Of these elements, which of the things are important in the life processes? This we need to understand that. So, which of these elements are important? So, therefore, this is concerned with, so we will try to understand what are the kinds of elements in the periodic table which are important. So, therefore, let us look at the aspects that are concerned with the role of elements in biology. What are the aspects that is concerned? So, when you say some of the elements are used by the life, which are the elements are used by the life? So, the question number one is that which are these elements essential for living cells in biology? And that is not sufficient enough. How much, what amount are these present? Okay, these two are there, and how come, who chooses this? Is also an important thing. It is also a very curious aspect. And then, so when you choose this, when you have one element, then no problem. When you have two elements, which one of these will have a more, which one of these will have a less? When you have three, when you have more than one element, there can be mutual interactions among themselves. Some may be dominant over the other, which I will explain you a little later on. They may make their friendship to a cooperative way, and they may extend their interactions even antagonistically. I will explain both these terms a bit later with proper connectivity, meaning as well as connectivity. Okay, so you have which are the things essential, how much amount they are there, who chooses all this, how are these being chosen, and whether you have any interactions in this. If so, where are these present? How are these present? A bit of it you already noted from my earlier slides, that they are present in the at least one of the things is that they are present in the enzymes, and how they are present I have not talked to you, we will see all this. So, they are there. What do they do in the biological systems? So, therefore, this is all is important when you look at the inorganic role of these elements in the biological, because as you can see there are so many elements are there, and not whether all these elements are essential or only part of these essential or elements are essential, that we need to understand this. For that these questions have arisen now at this stage. Okay. So, keeping these things aside, in the recent literature there are other queries have come up. How important is a particular element? When you say a particular element or a particular ion is important for a particular function, how important is this? How do we know how important is this? So, we will know what happens by asking a question. I will remove that ion, what happens to the enzyme? I will put another ion, what will happen to the enzyme? Whether the enzyme becomes a new enzyme, whether the enzyme becomes completely passive with no reactivity. So, these are some of the things in the modern concerns that have. So, when I replace one of the already present ion in the biological systems by another one, then what happens? I can not only change the ion that is being present, these ions are bound by the amino acid residues, which I will come later stage, and those residues I can also play with it. So, if I change the ion, if I change the amino acid residue, what will happen to the process of those enzymes. So, all these are additional recent concerns besides the concerns which I explained to you in the previous slide in that. Okay. So, therefore, what I would like to propose in this particular course is very generally speaking. So, we first need to look at the inorganic ions, inorganic species, and what their role in life is, and that is what I call as the introductory role. In fact, such an introductory role is very well suited to even to 12th standard students, to drag them or to attract them into taking a profession on the science kind of a profession. So, in fact, it can attract even the students of 12th standard thing. Of course, this is very useful for bachelor and master students as well too. And once I complete that, I would enter into the metalloproteins and metalloenzymes. It is a huge area, of which in the first stage I will just introduce what they are doing and etc. So, those are the things I will be looking at, and once I introduce what kind of a metalloproteins, metalloenzymes, their classification, their functions, all of these are briefly being mentioned, we will smoothly get into the next topic as a part 3 is how they function, what function and how they function. These I refer as the functional aspects of metalloproteins and metalloenzymes. This up to this, if you take it, it comes more of a biological inorganic chemistry. Now, I would like to add in my course not just the metalloproteins and metalloenzymes, I would like to take even the inorganic ions or inorganic species, how they interact with other biomolecules, how they interact with the cells, how they interact with the organs. These are some of the aspects I would like to introduce in this course as a very new component and a very elegant kind of a component to give a kind of a completion to the course that will be given in this. It is not only that, I also wanted to add another perspectives which are coming, where the inorganic ions, inorganic species, inorganic complexes acting like medicines, how, what and how, these are the some of the aspects. So, the overall I would like to sort of divide this into 5 parts, part of the inorganic ions and species in life, and introducing the metalloproteins and metalloenzymes, the functional aspects of metalloproteins and metalloenzymes, and then I would talk about the other biomolecules and cells, how the inorganics will interact with them and what their role in the medicinal aspects. So these are some of the coverage aspects of this particular course at this stage. Okay, having mentioned that what I said that we will try to go through these 5 parts of the topics, the initial introduction or the inorganic ions and species, then just introduce the metalloproteins and metalloenzymes, what they do, etc., and how diverse they are, and then go into how they are doing it. That is called function. So, the functional aspects of these metalloproteins and metalloenzymes. So, as I said, this particular part is mainly covered in the biological inorganic chemistry, but I would like to take up in this particular course a few more aspects. The aspects of the inorganics with other biomolecules and cells as well, and then also would like to see the inorganic ions and species, how they act in medicine kind of things. Okay. So with this let us again look back into this. So, the periodic table, you have the alkyl earth ions, you have the main group elements, you have a transition ions, and you have a inner transition ions in these things. Okay. So, we will get back to this a bit later. So, having seen this, now we need to identify which of the elements are important or which of the elements have been chosen by the life. So, for this I would take you back to 200 to 300 years back into the history of life. So, if you look at the history of life in the history of life, the essential elements, so as you can see, as early as in 17th century, people know that the iron is essential, and people have come to know in mid 19th century, which is 1850, people knew that the iodine is also important. In the early 1900s, people knew that the copper is essential, and then 1930s, people have started understanding this manganese is essential, zinc is essential, cobalt is essential. So many ions have been started adding to this one to the other. So, molybdenum then comes in 50s to 60s, molybdenum, selenium, chromium also. Some of them may look to you it's a puzzling, because some of these ions you may think that they are toxic. I will explain you that as well. And some more ions have been identified at a later stage in 70s, early 70s, like tin, vanadium, fluorine, silicon, etc. And bit later nickel, arsenic. You may say that arsenic is the poisonous. So, any element that you would come to know after a while can be poisonous when you have a large concentration, but they could be even essential elements at the lower concentration, which I will convince you in the next later few slides. And one step later, people have tried to find out that there is some role of lithium, bromine, cadmium, lead, etc., but not proven so much. And very recently, just about in the past, let us say 30-40 years, the tungsten has also been found to be involved. In fact, tungsten is not found to be involved in the normal life of the human, but is found in the life where the life grows at a very high temperature. Where is the life of high temperatures? In the lava. So, if you see, lava eruptions have got higher temperature, 300, 350, 400 degrees Celsius, where certain kind of a species, bacterial species grow, and in that the tungsten, and tungsten takes the role of molybdenum. Tungsten takes the role of the molybdenum in this. So, therefore, as we can see that this is the way that starting from last 200, 250 years, we have started learning, understanding the involvement of the ions or elements in the biological processes, even including the human body kind of thing. So, having seen such a kind of a hierarchical kind of a development, a chronological kind of a development, I am sorry, it is not a hierarchical, it is a chronological, because it is a time based. So, time based is referred as a chronological aspects. So, you know iron, then you know iodine, then you know copper, then you know zinc, then you know many other ions are required, but still they are limited in number, as you can see. Now, if you come and look at, now we take a big leap or jump and look at the composition of the human body. So, look at initially on the right side of this. So, on the right side of this, as you see that the body has a huge amount of water, 64, which is almost 2/3 is the water, and 1/5 is only the protein, and about 1/10 is the fat, and you have much less is the carbohydrate and some minerals, etc. So, whatever you have, real important elements are all within this particular thing. So, water being the maximum, followed by protein, followed by fat, and the remaining. But it is very essential to understand what these elements present in these mineral category we will come to know in a while. Instead of looking at this kind of a compositional way, let us look at the elemental type of compositional way. So, the elemental type of compositional way is that the maximum element in all this is oxygen. It is 2/3 going 2/3 with the water, 2/3 of the oxygen. And then you have a carbon, which is about 18%. You see the protein is 20%, you can see the carbon is 18%. So, it goes very well with it. That means most of the carbon is coming from the protein, most of the oxygen is coming from the water, etc., etc. And then you have 10% of the hydrogen, because hydrogen is present in the protein as well as in the water and other things. These other is very essential and important, and that is what we need to understand, highlight these things, and that is what is going to be important in this particular course on inorganic chemistry of life in this. So, let us go to the little further. So, having said that, we have carbon, oxygen, nitrogen, hydrogen, and you see on this carbon is around 18.5, oxygen 64.8, nitrogen 3.2, hydrogen 9.5. See, you add them all together, you will get something like 96%. That means we as a human bodies, we are so fat, but in this fatty body what we have is mainly these elements. Let us look at these. As I mentioned in the previous slide, the carbon, oxygen, nitrogen, hydrogen, these are present in 18.5% carbon, 64.8% oxygen, 3.2% of nitrogen and 9.5% of the hydrogen. So, these are the kinds of major elements. If we add them together, you will get a big 96. Big 4, the 4 is 4 elements. The big 4 is because the whole body is dictated, the whole body composition, the whole body weight is dictated by the big 4. The big 4 is this. So, will you be happy to have these 4 and have nothing else? And if so, then you will not be functioning as a human. Then you will be just functioning like just as a fatty body, nothing more than that. Then what you need to have a human life? To human life, you need not only the fatty body components like these 4, but you also need certain major elements. These major elements are macrominerals, also referred as macrominerals, and these are calcium, the potassium, sodium, the phosphorus, sulfur, chloride, of course magnesium, all of these. So, these are major elements. So, after these 96% you have these 3.9%. What is left? The left is 100 minus 96 plus 3.9, it becomes 0.1. So, the 0.1 is the one which you are seeing. So, obviously 0.1. So, when you have a 0.1, what do you understand? That 0.1 obviously is very small when you compare with 100. So, therefore, this is 1,000th part of 100% of that. So, you have something when very such a small, you call it as a trace. So, the word trace is coming from the concentrations that you present, but not their role is trace. Their role is very important. So, if you have big 4 elements, you will have fatty body, you will not have any life at all. Then you have this big 4 plus major elements, you have a strong body, you have a fat, you have a strong body, but still you cannot do functions. So, if you have the big 4, you have the macrominerals and you also have the trace elements, then you are a perfect human body, where what I mean by perfect human body is that you can really function like a human body. So, from this slide what you need to understand, just having 96% is not good enough to say that I am a human being. I cannot function like a human being. Suppose you take an exam, and if you get a 96% marks, you are absolutely happy. But you cannot be very happy if you have just these 4 elements. And then people who get 99.9% of the marks, they are of course absolutely toppers, and they will be flashed everywhere across the news media, and they are the top guys who will be selected by all the high level institutes, etc. But here, after adding 96 plus 3.9, 99.9, still I would say this is just a skeleton with some fat, but nothing more than that, no life in it. So, if I want to add life to this, I have to add trace elements, this 0.1%. So, for a bioinorganic chemist, biological inorganic chemistry, and if you want to have real life of your body, it is the 4 elements, big 4 elements, macro minerals are not sufficient enough, you need to have all the trace elements. So, it is like you know, you used to hear the Lord Brahma makes the human body. First you make the body, then you put what is essential components, then you put what will be for the function. It is exactly similar way that you would see over here too. So, therefore, we are going to have an important entire course which is dependent on these trace elements, mostly to some extent these elements as well, but nothing on the carbon, oxygen, nitrogen, hydrogen at all in this particular course. We do not need that. So, therefore, a healthy body requires not only the bulk elements like big 4, not only the macro minerals, all these 7, you also need all these about dozen trace elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, these dozen essential elements are absolutely important in that. So, having said that, let me recapitulate what we have said in the previous slide, and trying to explain and make you to understand, made this into categories. So, therefore, the elements that are required to bulk are called carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. These are all involved in making the main molecular mantle, like for example, proteins, for example, nucleic acids, polysaccharides, lipids. They are all formed from carbon, hydrogen, nitrogen, oxygen, phosphorus and sulfur. So, therefore, your whole body is built with these ones. Then the macro minerals and some of the ions like sodium, potassium, magnesium, calcium, and then chloride, phosphate, sulfate, etc. So, all of these are also important, and as you have seen from the previous slide, that together all of these is greater than 99. In fact, this is 99.1. So, the rest is the category 3. So, in this category 3 is the one, as I said earlier, is absolutely important. So, who gives the life to the body, human body? It is these elements which will add the life to the body. If these elements are not there, life is removed from the body, and it is basically non-functional body. So, non-functional body to a functional body. So, therefore, you require the trace elements to be added into that. So, in this, depending upon the concentrations, this can be divided into 2 parts, and in the first part we call it as a trace, and the second part we call it as ultra trace. So, trace elements are those where these are present about a couple of grams per 70 kilograms body weight, a couple of grams per 70 kilograms of body weight. So, such kind of things are trace elements, and those which are present a few milligrams for a body weight of 70 kilograms of body weight, and they are called ultra trace. Both trace and ultra trace elements are very important in life, and these are the ones which add life to you, basically the body. And of these, let us make one next categorization is the metals and the non-metals kind of thing. So, therefore, you have a manganese, you have molybdenum, cobalt, chromium, vanadium, nickel, cadmium, lead, lithium. These are coming from the metal direction, and there are some non-metals are also coming up, and these non-metals are fluoride, are fluorine, iodine, selenium, silicon, arsenic, boron. Some of these may think little unusual to you. I will explain that now a little and more later. So, I will tell you the silicon, obviously very small amount of silicon is required, very trace ultra trace amounts of silicon is required, but it is not found in any of the enzyme yet. The arsenic, very small amounts of the arsenic is required, but it is not found in any of the enzyme, but still they are required at very small concentrations of these ones. So, now you understand the life means it is not just the fat containing body. Life does not mean fat plus the macrominerals. The life, human life means the fat containing aspects, macromineral containing aspects and the trace elements. So, therefore, I would like to sort of define a human life in the following way. So, fat items plus macrominerals plus, I will write in a different color this one, it is the trace and ultra trace elements. Okay. So, the human life, if you are emphasizing on the term life, so that life comes only when you add these. When you do not add this, there is no life at all. So, therefore, so these are some of the important aspects that one need to be realizing that. Okay. So, without this, just the fat items, the fat body, and with the macrominerals you will have a strong body, but you will not have any functional. That fat plus macrominerals plus the trace elements that if you make, then becomes absolutely a full life of these. So, to sum up what I have talked to you is, in the first part of the lecture I have talked to you the inorganic elements are present in some aspects such as called the enzymes, but I have not explained you how they are. Then the next stage we have looked at which are the ions in the periodic table are important, and that also we have looked at, and only certain kind of elements. Then we have looked at the chronological order, how this has come up from very early days, knowing from iron to iodine to copper, etc., and several more of this. And then we know what is the composition today, human body composition. Human body composition we have looked at the 4 elements like carbon, nitrogen, oxygen, these kinds of elements will make the total body weight into more than 99%, and then there are some elements which are basically called macrominerals, together is 99.9, and it is that 0.1% of the elements which we categorized as trace and ultra trace elements, and these trace and ultra trace elements indeed add life to the body, and then you can say just life is really human life only when you add all this. This is where in this particular lecture that I would like to focus. Then we will see the aspects following that, how these are, where these are present, and those kind of details will be seen in the next lecture. Thank you very much.